Okay, let's look at this example then of a beam that is not pivoted at its midpoint. So you can see here, the question tells us that the beam is 50 centimeters long, and that's not on our diagram. So the first thing I would do would be to add that and say, okay, this is 50 centimeters long. I should put that in the middle. Now, the fact that this uses the word uniform beam means it's the same thickness the whole way along. And we know from year 10 work that any sort of rectangle has a center of mass in what do we call the center, okay, because it has those two axes of symmetry. And we can take that center of mass or center of gravity to be where we take the weight to act from. So, the other thing I can tell from this that isn't marked on the diagram, is usually the first thing you have to do, is I can tell that halfway along that object is where the weight acts. Now, by halfway along the object, well, if it's 50 centimeters long in total, that means that is 25 centimeters from either end. Okay, once we've done that, that's us ready to start this question, really. We're trying to find out what W is here, the weight of the object, okay, the downwards force due to gravity. And we're told it's balanced, and if it balances, we know that the clockwise moment and anti-clockwise moment are the same about the pivot. But here's our pivot, and that's the key thing. You can't just use the distances you're given in these questions. You usually have to work out some additional distances, and the distances we need are the distance from the pivot to the forces. So in this case, the distance of our weight from the pivot is from there to there. Now, I know this is 25 centimeters. I know this is 20. So for the 20 plus this to equal 25, this distance in here needs to be 5 centimeters. Likewise, we need the distance that the 12 Newton force is from the pivot. But we know that this is 6, plus this would have to equal 20. Okay, so just looking at the dimensions. Therefore, this must be 14 centimeters, because remember, this here is 6, so 14 plus 6 equals 20. And then once we have that, it becomes a much easier question. That's the hard part. So we've got this force W. The force W is 5 centimeters from the pivot. The 12 Newton force is 14 centimeters from the pivot. And after that, it's just a straightforward principle of moments question. So we do anti-clockwise moment, force times distance equals clockwise moment, force times distance, 12 times 14 equals W times 5. 12 times 14 is 168, is equal to 5W. Divide both sides by 5. And it gives us 33.6 newtons, okay? So the key thing to remember is the weight acts from the center of mass or center of gravity of the object, which is usually just what you would term the middle of the object, so halfway along. And the other thing to remember is when you're using and calculating moments, the distance has to be the distance from the pivot. And quite often you'll have to look at the geometry and dimensions that are given and then figure out what those distances of the two forces are from that pivot. Okay? Hope that helps.